So now let's look at geometric series. These will have a very specific form. It will look like something, a constant times r to the n. So there's a number as the base and n is the exponent. This is geometric. Don't confuse this with a p-series where you have n to a number, a p-series, or we'll write it as p, n to the p, n to the negative p. It's a p-series. So make sure you are able to recognize the difference. Geometric series are real nice, and this will be one of two series where you may be asked to actually find the sum of the series. The other ones you just want to know if they converge or diverge. There's only one requirement on a geometric series. You have to identify your r value, and you have to make sure that the absolute value of r is less than 1. If it is, this implies that your series converges. Otherwise it diverges. So this is the only way it converges, so else it diverges. Okay. If it converges, so your book will have two formulas for the sum. We only need one. If the series converges, geometric series, starting at n equals m, then it converges to c over cm, let's say c times r to the m divided by 1 minus r. And that's it. One of the more easier theories to deal with. So let's look at a few examples. Okay, so we have a number being raised to the n. Our r value is pi. The absolute value of pi is not less than 1, so series diverges. Let's look at another example. Okay, so you may be tempted to think that your r value is 5. It's not. Remember that a geometric series has a very specific form. It has to be r to the n. We don't have that. We have r to the negative n, or we have 5 to the negative n. So we can write this instead as a series n equals 4 to infinity of 3 times 1 over 5 to the n, using our properties of exponents. Now we see that r is 1/5. Absolute value of 1/5 is in fact less than 1. Our series converges, and because it's geometric, we can actually find the sum. So using our formula, our C is 3, our R is 1/5, our M, our starting number, is 4, and then over 1 minus R. Okay, another example. So let's approach this the same way. We want to make sure it's to the n to start with. So we have a fraction to a negative exponent. We can just flip the fraction to make the exponent positive. Okay, now our absolute value, our R value is e over pi, and the absolute value of e over pi, well, remember that e is about 2 point something, pi is about 3 point something, 3.14. So the denominator is a bit bigger than e, the numerator, so this is less than 1. And so our series does converge. So series converges to, and we use our formula, we get, here our C is 1, so this is 1 times e over pi to the m, our m is 0, divided by 1 minus e over pi. This one we can clean up a bit. 1, e, anything to the 0 is just 1. So this is 1 minus e over pi. Let's look at a more complicated example. Okay. Okay. This is a pretty ugly series, but we can split it up. This becomes 3 to the n over 4 to the n minus 4 times 12 to the n over 4 to the n. Now, we can turn this into two different series now. This is, I'm going to clean this up a bit. This is 3 over 4 all to the n. I'm going to subtract the series of this expression, 4, and then now this becomes 12 over 4 to the n. So we'll consider these in two different steps. Here the r value is 3 over 4. Here the r value is 12 over 4. So this series here converges because 3/4 is less than 1. This one diverges because 12 over 4 is greater than 1. Well, if any part of our series diverges, then the whole thing diverges. If you have 100 different terms in your series and 99 of them converge and one diverges, then the whole series diverges. Okay. Let's look at maybe one more. Okay, let's look at this series. This is a bit ugly. It's okay. I'll just rewrite it a bit. So we'll say this is 1 over 1/4 to the negative n, and that's being raised to the 1/2. Okay, and that's equal to 1 over 1/4 to the negative, let's see, and we'll write this as negative n over 2, it's the exponent, which is equal to 1/4 to the positive n over 2, which is equal to 1/4. So we can say this is 1/4 to the 1/2 to the n. And then the square root of 1/4 is just 1/2 to the n. And so our r is 1/2. Absolute value of 1/2 is less than 1. That means our series converges and it converges to our c is just 1 times r 1/2 to the m, which is 5, divided by 1 minus 1/2. And we may as well clean this one up because we can. 1/2 to the 5th, that's 1 over 32. 1 minus 1/2 is 1/2, which is equal to 2 over 32, which is 1 over 16. So that's geometric series.